starts moving and then it starts rolling on itself along the slope. Why does this happen? Now, when the ball was rolling along this slope, was there somebody who was doing some external work from behind? No. So you applied this trigger. So this force which was applied here was the trigger to start this movement of the ball. So similarly, there is a trigger which initiates the charge flow and then the charge keeps on flowing. Similarly, let us suppose if you have a hot cup of coffee placed on a table. What happens if you keep the coffee as it is for some time? What happens? The coffee becomes colder. Why does that happen? That's because since the temperature of the coffee is very high as compared to the temperature of the surroundings, heat energy starts flowing from a region of higher temperature towards a region of lower temperature. So gradually heat energy starts flowing from the coffee towards the surroundings. So the coffee keeps on losing heat and as a result, the temperature of the coffee reduces. So what was the trigger in this case? In this case, the trigger was the change in temperature. Since there was a difference in temperature between the coffee and the surroundings, so there was a flow of energy. Similarly, in case of a copper wire, for example, why does this piece of copper wire conduct current? I mean, why does the charges flow within this copper wire, or when will the charge flow inside this copper wire? Charges flows due to a difference in potential between the two ends. If there is a difference in potential between these two ends of the wire, difference in potential or difference in electric pressure between the two ends of the wire, then the charges will flow from region of higher potential towards the region of lower potential. So if we say that this end is at a greater potential as compared to this end, then there will be flow of charges from this end to this end, and this flow of charges constitute current. Right? So if we say that this end is negative as compared to this end, that means this end has more electrons as compared to this end. So due to the difference in number of electrons, electrons will start moving from this end to the other end. So these flow of charges constitute electric current. So difference in potential between the two ends of a conductor gives rise to the flow of charges, and this flow of charges constitute electric current. Now, how is this potential difference produced? How will you produce this difference in potential between the two ends? Now, potential difference can be produced by a battery or by a combination of one or more cells. In fact, that is the purpose of a battery. If in your chemistry lessons, you would have studied the working of a cell. How does a cell works? So what is the purpose of a cell? The internal structure of the cell is such that chemical energy gets converted into electrical energy inside a cell. Therefore, this cell or a combination of cells, which is also known as battery, they are used to provide electrical energy, or they are used to produce potential difference between its two ends so that charge flow can be initiated. You would have seen, if you would have observed any battery carefully, you would see that any battery would have a plus end and a minus end. This shows that one end is positive with respect to the other end. So this shows that there is a difference in potential between the two ends, which will initiate a charge flow when this battery is connected to a circuit. Right? So you understand what causes the charge flow? Difference in potential between the two ends of a conductor initiates charge flow. Let us now introduce electric potential and potential difference. What do I mean by electric potential difference and electric potential? Now, when I talk about electric potential difference, it is nothing but the work required to be done by an external force in moving a charge from one point to another. Let us suppose you have a charge, any charge particle of charge Q. So if you want to take this charge particle from this point A to this point B, some work needs to be done. So the work that needs to be done to move a charge from one point to another point is known as electric potential difference. Because a charge particle will move from one point to another point only when there is a gradient. So this is basically known as electric potential difference. And what is electric potential? Electric potential is nothing but the work done per unit charge in bringing the charge from infinity to that point against electrostatic force. That means, let us suppose I have some charge particle, right? In bringing this charge particle from infinity to a specific point A, whatever is the work done, that is called potential. So what will be the potential of A? Potential of A is the work done in bringing this charged particle from infinity to A. Similarly, what would be the potential at this point B? It would be the work done in bringing this particle from infinity to point B. So that would be the potential at point B. Now what would be the potential difference? The potential difference between A and B will be nothing but the difference of VA and VB. So the difference in potentials, that is the work done in taking the object from point A to point B, becomes the potential difference. So you understand what is potential at A? Work done is in bringing the charge from infinity to A. What is the potential at B? Work done in bringing the charge from infinity to B. What is potential difference between A and B? It is the work done in bringing the charge particle from A to B. So that becomes VA minus VB. Okay. Because this entire thing, infinity to VB, infinity to B is VB, infinity to A is VA, and so VB minus VA is the work done in taking the particle from A to B. Simple, right? So this is how we define electric potential difference and electric potential. So how do we measure potential difference? Potential difference is generally measured by an instrument called voltmeter. So how do we connect a voltmeter in order to measure potential difference? It is connected in parallel across the points between which the potential difference is to be measured. Let us suppose I want to measure the potential difference between these 2 points. So I connect a voltmeter across these 2 points. So the reading of this voltmeter will tell me the potential difference between these 2 points. SI unit of potential difference is volt. Potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other point. This is how we define 1 volt. What is 1 volt? Because as per the definition in the previous slide, we can say that potential is nothing but work done per unit charge. Right? So this is how we define potential. So how do I define 1 volt? 1 volt is nothing but when 1 joule of work is done in moving a charge of 1 coulomb from one point to another. Then we say that the potential difference is 1 volt.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.